Hello, everyone. This is the lecture for section 7.2, Sum and Difference Identities. So in section 7.1, I know we took a long time with it. Um, in section 7.1, I showed everybody, or we tried to, right? And this was the shared frustration, that if I gave you a certain identity, or if I gave you certain equations, right, you can use the identities that we currently know up to that point to either solve or prove other trig identities, right? Okay. The overall goal for 7.1 was to show everyone how to, at least in procedurally, right? Not be good at it, just so that, just to be clear, um, just so that everybody had an exposure to how to prove an identity. That's it, right? Uh, 7.2, 7.3, 7.4 is just going to be me giving you other new identities, trigonometric identities that you can use for proving much more complicated trigonometric identities. Okay. 7.2 deals with sum and difference identities. Okay. uh, and it's really exactly how it looks like. I'm giving you new ones. So if you have the addition of two angles inside of cosine, that's equal to this. Just make sure you get your alphas and betas correct. If you have the subtraction of two angles inside cosine, then it's equal to this. It's really that simple, okay? Those are the ones for cosine. Here are the ones for sine, and here are the ones for tangent, okay? Uh, These are all in your trifold, in that trig trifold that I handed out, okay? So you don't need to write these down anywhere. You could just refer to them in the with that sort of like big, huge cheat sheet that I gave you, okay? Now, you guys are probably asking how, why, right? Um, do not worry about the how. Do not worry about the why, right? Be worried more about how to use these. That's what I'm more concentrating on, okay? The proof for all six of these that are on the screen right now, uh, the proof for all six of these is very elegant. It's very nice. It is very mathy. It makes me, makes me feel tingles inside, okay? Okay, but for the majority of you, you won't need to know that, okay? If you do want to know that, okay, the proof is in chapter 7. I believe it is. Okay. Um, I'm not going to concentrate on that. I'm more worried about you being able to use these. Okay. For the applicational purposes. Right. Okay. If you do want to find out the proof, like I said, chapter 7, and if that's the case, you're probably going to be studying math for the rest of your life. So, okay. So let me go ahead and do the very first example. Okay. So let's say I want to find this value right here. Cosine of 5 pi over 4 minus pi over 6. Okay? Okay. What I want to do first is I want to find out what the heck that is. So if I do 5 pi over 4 minus pi over 6, right? Okay. Uh, I'm going to do common denominators first. Okay. So 5 pi, actually, use my red pen. This one is missing a times 3, right? And this one's missing a times 2. So I'm thinking the common denominators are going to be 12. Okay. Uh, 3 times 5, that's going to be 15 pi minus, and then 2 times that's going to be 2 pi. There we go. So what I have here is this. 15 pi over 12 minus 2 pi over 12. That's going to be 13 pi over 12. And I'm going to move this over a little bit because I want to sort of add something in. Okay. What we are essentially finding, right, when we do this, okay, we are finding cosine of 13 pi over 12. These are the exact same thing because I did the math over there on the right. Okay. Now, I do want to point this out. Okay. You guys ready for this? Okay. 13 pi over 12, it is not on the unit circle. We have no information for it, right? But these two angles, 5 pi over 4 and pi over 6, are on the unit circle. So we can construct, so notice what's happening, we can construct cosine, sines, and tangents of angles that are not on the unit circle with stuff that is on the unit circle, okay? Expanding that a little farther, right, we can find information for unknown angles if we have information for known angles, okay? Okay, now, that's the sort of overarching thing here with these, okay? That's what they're used for, okay? Pragmatically, right, in terms of our application, we just need to know how to use it, right? So I'm going to write down the one for cosine, since this is a subtraction, right? So it's going to be cosine of alpha minus beta, right? We're going to use this one. It's going to be cosine alpha, and I'm going to put it in parentheses, cosine beta, okay, plus sine alpha, whoops, I'm going to put it in parentheses, sine of beta. This is the formula from your worksheet, flat out, okay? All that's left now is I need to identify my alpha and my beta. I'm just going to go ahead, alpha, beta, okay? Equal to, I know what my alpha is, that's 5 pi over 4. My beta is pi over 6 plus cosine, sine of alpha, which is 5 pi over 4, sine of pi over 6. All of these values are known to us. All of these values are known to us, right? So off to the races. Make sure you have your unit circle out, okay? Cosine, 5 pi over 4. That is negative root 2 over 2. Cosine of pi over 6, square root of 3 over 2, plus sine of 5 pi over 4, negative root 2 over 2. And then sine of pi over 6, 1/2. You multiply these things out, right? You're going to get, if you do square root of 2 times the square root of 3, that's going to be the square root of 6. There was a negative out front. 2 times 2 is 4, plus, yeah, I'm going to leave it that way. Square root of 2, there's a negative out front. And then 2 times 2 is 4. So this is equal to negative root 6 minus square root of 2 over 4. We are done. So this still works out the same way that we were explaining the unit circle, right? That I just found cosine. This is the x portion, right, of this particular angle. Okay, if we wanted to find the sine, then I'd have to do the same thing, but it'd be sine of 13 pi over 2, right? That's it. That's it. That's all I want. That's all I want. Okay. Okay. So in this one, in example 1, I gave you the breakup. I gave you the 5 pi over 4 and the pi over 6. That made the 13 pi over 12, right? Most of the time, you get something that looks like this, sine of 75 degrees. That's going to be one of the WTFs. Like, what do I do, right? Well, however you can figure it out is fine. So, give me 2 angles, right, that make up 75 degrees. I'll give you the answer for that, right? 75 is the same thing as 45 degrees, right, plus 30 degrees. Done, right? So 75 degrees is not on my unit circle, but 45 degrees and 30 degrees is. So then this is the same thing as saying, actually, let me pick it up, move it over a little bit, right? This is the same thing as saying sine of 45 degrees plus 30 degrees. Okay, so I'm going to write down the one for sine. So sine, and this is an addition. Hopefully you guys see that, right? So sine of some alpha plus some beta. Go to your worksheet. That's going to be sine alpha cosine of beta plus cosine alpha sine beta. Okay, all that's left, we need to assign our alpha and beta. So alpha, beta, okay, equal to sine of alpha, 45 degrees, cosine of beta, 30 degrees, plus cosine of 45 degrees, sine of beta, which is 30 degrees, sine of 45, that is square root of 2 over 2, right? Whoops, that's supposed to be a parentheses. Okay. Cosine of 30 degrees is square root of 3 over 2 plus cosine of 45, that's root 3, whoops, root 2 over 2, sorry. Sine of 30 degrees, right? That is 1/2. Square root of 6 over 4 plus square root of 2 over 4, square root of 6 plus square root of 2 over 4. We are done. Now, I got to mention this, okay? I got to mention this. Please do not add the tops. So this is not square root of 8, okay? There's no rule. If you guys remember, I know it's been a little while, right? But when we were doing exponentiation, there was no rule for adding together two things that were inside a square root. Okay? So please do not do that. Please, 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 please. Okay? All right. That's it. That is it. Next thing up, quick checks. I'm getting you guys to do some quick checks here. Okay? I do want to mention this, and I want to mention it for the second quick check, because this is probably going to come up. This is going to be a question that's going to come up. Do we really need the tangent ones? Not really. Not really. I'd rather you know them and not need them than the other way around. Okay. In all of my travels, I've seen the sine and the cosine ones for sure, multiple times, right? I've had to use them myself multiple times. Have I had to use the tangent ones? No. Okay. Just keep them in the back of your mind. Just know that they exist. Okay. That's it. Okay. We'll practice these during class. Okay. So don't get too worried. Okay. So now that we know these identities, right? Now that we know these new equations, right? We can use them to prove other various more difficult identities, right? So I'm going to do one, okay? I want to show that this is true, okay? Now, the same rules that I covered in section 7.1 still are valid here, right? So I can grab the left-hand side, turn it into the right, grab the right-hand side, turn it into the left, grab both ends, make them into something common, right? Or grab both ends and make them into, and turn the whole entire thing into a already known common trig identity that we've already known. Got it? Okay. Those rules still work. So for this one, okay, I'm going to start with the left-hand side. I'm going to turn it into the right-hand side. Remember how I said I want to mess with the most messiest side, the one that gives me the most room to play, right? So I'm going to use the left-hand side, and I'm going to try to turn it into the right. Okay. Here we go. So I'm going to grab this, right? Sine alpha plus beta plus sine alpha minus beta. Okay? And let me get my equations out again. There we go. Okay. Uh, and I'm going to try to turn it into this. Okay. Now, we know these equations already because that's from the worksheet up above, right? So if you look at your worksheets, alpha plus beta, so it's going to be sine alpha. Yeah. Cosine beta plus cosine alpha sine beta. Do you need to memorize? I mean, if you want to. I just know that they exist and I always look them up because I don't bother. I don't want to memorize stuff that I can easily use the Einstein method. Don't ever memorize something you can look up. Uh, Subtraction one. That's going to be sine alpha cosine beta. Okay. Minus. Where am I? There we go. Cosine. I got to read the right one. Cosine alpha sine beta, okay? And hopefully people don't stroke out after this. That one is all of this. And this one is all of this. Okay. All right. Let me get rid of the colors before you guys lose your eyesight. Equal. I want you guys to notice this, right? Here's the negative of something, right? Minus cosine alpha sine beta plus cosine alpha sine beta. So guess what happens there? Bam, bam. Those are gone. So I get left with these two. Eh, eh. And look at, they're the same thing. Since we have two of them, guess what? 2 sine alpha cosine beta. We are done. Now, hopefully you guys see this, and this actually tends to be very much true. Once we start covering some more of the sort of standard trigonometric identities, proofs become very simple, very quick, very easy, because you're collapsing a lot of knowledge, you're collapsing a lot of steps into identities that we don't need to prove, like this one, like all of these, like the sum and difference identities that I just showed you. Okay. After this, quick checks. We'll do these in class, and then lecture questions. Okay, we'll practice these all in class. Okay, I've got you doing a couple of trigonometric identities right there. Okay, any questions? If there's any questions, ask me during our quick check time, or just come downstairs to the math lab. Okay. Besides that, happy studying.